Portland cement concrete. It's one strong material. It can support tons upon tons of traffic day in and day out for years with very little upkeep, but then problems. It's going to happen sooner or later. Patching is inevitable. For small problems only a few inches deep, spall repairs are called for. Those procedures are dealt with in another program. In this program, Concrete Pavement Patching, I'm going to discuss the larger jobs, Type A and Type B patches. These patches always cover the width of at least one full traffic lane, and they go through the full depth of the pavement. Their length can vary. For Type A, anywhere from 6 to 65 feet long. Type B patches cover from 65 to 500 feet. The details vary, depending on whether the pavement is going to be overlaid after patching and whether only one lane or both lanes are being patched. To illustrate the procedures, I'm going to show you a typical job. One lane only with no bituminous overlay. I'm going to cover these topics: preparing the area, patching joints, placing the concrete, finishing, curing, and joint sealing. Then I'll go into some of the details on joint construction. So let's get started. Preparing the area. But first, I want to tell you something right at the outset. There are a lot of numbers and details involved. Luckily, you don't have to memorize them all. You'll have the contract, the special provisions, and the specs to use as references. Get familiar with them before the work starts. It's more important to know where to find the details than it is to know all of them by heart. Basically, patching is a fairly simple operation. It's a matter of using a concrete saw to cut around the area to be patched. Lifting the old concrete out, constructing joints between the new concrete and the existing pavement, and placing new concrete and finishing it. But there is a lot to inspect. Let's have a look, starting with preparing the area. Like any other project, your first responsibility is to ensure that all the proper traffic control devices are in place. That means both before and through the work area. Next, make sure that the area to be patched has been marked before the contractor starts working. If it hasn't been marked, tell your supervisor. Patching begins with a full depth saw cut down the longitudinal joint for the full length of the patch. Then a full depth saw cut is made at each end of the patch. Sometimes when the concrete is under a lot of pressure, the contractor will make two saw cuts to reach the full depth. The first cut is shallow and helps to relieve the pressure. Another way to relieve the pressure is to cut a wedge in the concrete. The contractor makes two shallow cuts, this time alongside each other, anywhere within the patch. Then the concrete between the cuts can be removed using light air hammers and hand tools. In any case, the end result has to be this: 3 saw cuts through the full depth of the pavement. And because the saw blade is circular, the cuts must cross each other completely at the corners. Here's why. If the saw cuts are not full depth, breakback will occur when the slab is lifted out. The good concrete outside the repair area will be damaged. If that happens, make sure the patch is extended to include the damaged section. And be sure to record the extension in your diary. It'll be done at the contractor's expense. Watch closely as the center section is lifted out. The contractor has to be careful at this point as well, because if the slab damages the good pavement, another saw cut has to be made and the patch extended. Again, all at the contractor's expense. The face of the adjacent pavement has to be in good condition. Any damage to the shoulder has to be repaired at the contractor's expense too. so the operator should be careful in lifting and disposing of the old concrete. Once the slab is out, you should take a look at the edge of the old pavement. Sometimes in saw cutting, downward pressure can cause the underside of the pavement to break back, which weakens that area. If there's a horizontal crack, the contractor has to make another saw cut. As I said, the face of the adjacent pavement has to be in good condition. All right, the saw cuts were okay. The subbase is your next inspection point. The whole reason for lifting the old slab out instead of breaking it in place and excavating is to avoid damaging the subbase. If more than an inch or so has been disturbed, the loose material has to be removed. Some disturbance, minor scuffing, is to be expected. That can be corrected simply by using a small vibratory compactor. If the subbase is absolutely unsuitable, unable to serve as a foundation, the engineer will direct the contractor to remove and replace it, much as if it were new construction. Steel or wooden forms are required wherever the new concrete will not be supported by the existing pavement. Make sure the forms are solidly braced so they'll maintain the proper position, and make sure that any joints that are formed are vertical. One more point about preparing the area: make sure a polyethylene bond breaker is installed along the longitudinal joint wherever Type A patches are constructed. That prevents bonding and reduces friction between the new concrete and the old pavement. And that covers the preparations. Now, patching joints. A patching joint is a transverse joint with dowels at the beginning and end of the pavement patch. Here's where we want to end up: a series of dowels embedded about halfway into the existing slab and held tight by epoxy or some other approved anchoring material. The dowels are 16 inches long, 1 1/4 inch in diameter. They're pre-coated or galvanized to prevent corrosion. The dowels serve the same purpose as the pins in a dining room table. They add strength and stability at the one point where it's needed the most: in the joint. 8 dowels are required at each end of the patch, and the spacing is shown on the standard drawings. But for ease of construction, the contractor can install up to 12 dowels if he desires. Handheld drills are not permitted. The drill has to be mounted in a frame that will maintain the proper horizontal and vertical alignment throughout the drilling process. All holes have to be parallel to the surface of the pavement and parallel to the longitudinal joint. The holes should normally be centered vertically, but they can be moved up or down 1 inch if there is reinforcing steel in the center. The diameter of the holes is 1/8 inch larger than the dowels, and the holes have to be deep enough to get the dowels at least 7.5 inches into the concrete. So because the dowels are 16 inches long, no more than 8.5 inches should extend out of the hole. Okay, the holes are drilled. Now the bars can be placed. As I said earlier, the bars have to be held firmly in place by epoxy or some other approved anchoring material. Here are some acceptable methods. One way is to just coat the bar before placing it. If the contractor is using this method, be sure that the section of the bar placed in the hole is covered completely and uniformly. All void areas should be filled. Another method is to use a 2-part mixture of epoxy in a capsule. The capsule is placed in the hole first, then the contractor drills the bar into place. The spinning action of the bar first breaks the capsule and then stirs the mixture to form the epoxy. Again, both methods are acceptable, so long as the bars are held firmly in place and are parallel to the longitudinal joint and the surface of the pavement. After the epoxy has set up, the exposed portion of each dowel is coated with graphite to prevent the new concrete from bonding to it. Again, make sure that each dowel is coated completely and uniformly, and that covers doweling the patching joints. Now, placing the concrete. Obviously, a high-quality patch calls for high-quality concrete, either Class AA or high early strength. And of course, there are testing requirements: slump, air content, and cylinders. There are separate videotapes on sampling and testing concrete. Refer to those courses for the details. You are responsible for making sure the concrete's within the specs. So here's a summary of your duties. Collect all delivery tickets. Note the time of delivery and the revolution counter reading on the truck. The contractor does the actual sampling and testing, but you witness. Sampling the concrete, running the slump tests and the air content tests, and casting cylinders to be sent to the lab for testing. If the subbase is bone dry, it can pull water out of the concrete, so it should be moistened a bit. But of course, no puddles. Now we're ready to place the concrete. Notice I said place. The concrete chute should be less than 4 feet above the surface, so it doesn't drop the concrete, and the chute should be moved across the area to spread it out. As soon as possible, the crew starts consolidating the concrete with a vibrator. The vibrator should be dropped right down to the subbase. It has to be done quickly, though, or the concrete will segregate. Make sure they keep the vibrator moving. One important point about the vibrator: don't allow the contractor to use it to move the concrete around. The concrete will segregate, and that means a weak patch. Tell them to get out the shovels. Shoveling the concrete too much can also cause segregation, especially if it's done like this. If it has to be shoveled around, each shovelful should be flipped over and laid in as gently as possible. An approved mat of wire mesh reinforcement has to be laid in, 3.5 inches down from the surface, plus or minus 1 inch. Make sure the mesh sections are wired together securely, or overlap sufficiently to keep them from separating. The contractor can either place the bottom portion of the patch, lay in the mesh, and then place the top portion, or place all of the concrete at once, and then press the mat in. Either way is acceptable, as long as the minimum clearance between the mesh and the surface of the pavement is maintained. If it's being vibrated with the reinforcing mesh in place, the contractor should be careful not to rest the vibrator on the mesh, because the whole mesh will vibrate, and that can cause segregation. It has to be done quickly and carefully. Once the concrete is in place, we can go on to the next topic: finishing. It's important to get the new concrete flush with the old slabs next to it, including the wheel ruts. Ideally, the motorist should not feel the patch. Here's how it should be done. At first, the patch is slightly overfilled with concrete, and the excess is struck off with a straight edge, which is held parallel to the longitudinal joint. The concrete should be struck off by using a sawing motion from one side to the other. That way, the wheel ruts are built right into the patch. The idea, of course, is to get the patch to follow the contour of the surrounding pavement. No dip, no bump. On Type B patches, those over 65 feet long, the wheel ruts are tapered at the beginning and end of the patch. The center portion of the patch has a normal, straight cross slope. Actually, the initial strike-off just gives the patch a rough finish. Troweling and floating give the concrete a smoother, more even surface. Just make sure the float is pushed toward the center line of the road. That way, the patch follows the same contour as the surrounding pavement. Then comes texturing. Type B patches get textured transversely for the entire length of the patch. Type A patches, those shorter than 65 feet, should have the same texture as the surrounding pavement. So if the surrounding pavement is textured, texture the patch. If it's smooth, make the patch fairly smooth. Again, ideally, the motorist shouldn't feel the patch or hear it. And that's finishing. Now, curing the concrete. Curing basically means letting the concrete set up gradually, and that means maintaining a moist surface at the right temperature. Of course, to do that, the concrete has to be protected from the weather. The first step in curing is to cover the patch with water-saturated burlap as soon as possible. Make sure the burlap sections are overlapped so there are no gaps. Polyethylene sheeting over the burlap keeps the air out and the moisture in. Sometimes both the burlap and polyethylene are part of the same sheet. Again, the curing material is saturated with water before placing it on the patch. The next step is to give the patch an airtight seal, so see that the edges are secured. Here, they're shoveling dirt around the edges, but boards work just as well. Just make sure it's airtight, and that's it until the patch cures. How long it cures depends on the temperature. If the air temperature is above 35 degrees, then the concrete has to cure for 4 days. But if the air temperature goes below 35 for more than just a few hours, the concrete has to cure for 7 days. But no matter how long the curing period is, the temperature of the concrete always has to be above 40 degrees. Use a high-low thermometer to check the temperature. It records the highest and lowest temperature since the last time it was reset. Just leave the thermometer under the burlap and check it every day. After you've recorded the temperature, tap the thermometer a few times to reset it. If the concrete temperature ever falls below 40, tell the contractor right away so more protection can be added. The concrete needs more insulation. It's okay to use straw, hay, or additional polyethylene sheeting. In fact, any one or a combination of materials is just fine. The important thing is to keep the curing surface temperature above 40 degrees. And that's curing. Now sealing the joints. When the concrete is cured, a reservoir for the sealing is cut in the longitudinal and transverse joints. The longitudinal joint gets a 1/4 inch cut, 1 inch deep. The transverse joints are normally 1 inch deep and 1 inch wide, but the actual dimensions depend on the length of the patch. Be sure to check the special provisions. The top edges of the transverse joints are beveled. This helps prevent the raw concrete from breaking. And remember, the sealant can't be poured on the same day as the saw cuts are made because of all the cooling water that the saw uses. It needs at least 1 day to dry out. Then the saw cut has to be blown out to get rid of any stones or concrete chips. This step is critical. Water, debris, or dust in the saw cut will keep the sealant from sticking to the concrete, so make sure it's cleaned out thoroughly. Tape bond breaker is placed with the sticky side down, inside the saw cut. Make sure the tape covers the bottom of the cut, but not the sides. Finally, the reservoir is filled with an approved sealing material. That keeps water and debris out, and it allows for expansion and contraction. There should be enough sealant to almost fill the saw cuts. Make sure the sealing material is approved by the department, and check the application temperature. If the material comes in containers, check for a DOT sticker to see that it's approved. And read the manufacturer's label for the application temperature. Then read the thermometer on the heater. It has to be applied at the right temperature. And that covers sealing. Now the last section of the program, joint construction. In concrete pavement patching, there are 4 types of joints. Patching joints, at the beginning and end of the patch, expansion joints, new pavement joints, and longitudinal joints. We've already looked at patching joints and longitudinal joints, but not the other 2. If the patch replaces an existing expansion joint, and if the expansion joint in the adjacent lane is not going to be replaced, an expansion joint has to be constructed. It's precisely the same as the doweled patching joint. Smooth pavement face, drilled holes, dowels epoxied into place, exposed ends coated to prevent bonding. But 3/4-inch expansion joint material is tacked onto the existing pavement slab with holes cut for the dowels. And a tube with a minimum 1-inch clearance pocket is installed over the end of each dowel. The new concrete in the patch surrounds them, and they form a 1-inch space inside the patch. That way, the dowels have room to move when the concrete expands and contracts. The expansion joint should be installed at the end of the patch that's closest to the old expansion joint. New pavement joints are altogether different. In this case, load transfer units are installed. The units themselves are most commonly called baskets. They're placed across the patch next to each joint in the adjacent lane if only one lane is going to be patched. If both lanes are going to be patched, the baskets are placed every 40 feet. Make sure they're placed perpendicular to the roadway, not skewed like they would be for new concrete paving. Both ends of each basket have to be marked precisely so you can find the center line of the basket when it's under concrete. Because after the concrete is placed, a saw cut is made directly above each basket to make the concrete crack right there, in effect making two separate slabs that meet at the basket. Here's a close-up of a basket. The frame doesn't do anything but support the dowel bars when the concrete is placed. So, for the purposes of understanding how the joint works, ignore the frame. It's the dowel bars that are critical. Just like the pins in a table, the dowels in a new pavement joint have to be held tight on one side, and they have to be allowed to slip in and out of the other side. So 1/2 of each bar is coated with graphite lubricant. The concrete will bond to the uncoated side, and the lubricant lets the bar slide freely in the hole that it forms on the other side. And you'll notice that the graphite lubricant alternates. Left side, right side, left side, right side. 2 points about the lubricant. 1, it has to be applied at least 1 hour before the concrete is placed, to give it a chance to set up. And 2, the bar has to be coated all the way around, so check underneath. The dowel bars have to be parallel to the longitudinal joint, parallel to the surface of the pavement, and parallel to each other. Otherwise, they'll jam when the concrete sets up. That would cause serious damage. Just by eyeballing, you can tell that this bar is going to cause problems. Look at each bar in each basket. Here the contractor has built an adjustable level to check the baskets. He adjusts the height of the legs to get a level reading from the top of the subbase. Then he sets it down on each dowel bar. Other techniques are okay too, as long as the bars are parallel to the longitudinal joint and surface of the pavement. Once the basket has been positioned, it's staked in tight to keep it from moving when the concrete is placed. The baskets are shipped with tie wires to hold the frame together and with clip angles to hold the rods in place. All tie wires must be cut, and all clip angles have to be removed before the concrete is placed. Otherwise, the joint simply will not function properly. Then after the concrete is placed, an initial saw cut is made over the center line of the basket. It should be done as soon as the patch can support the saw without damaging the concrete. And it has to be done quickly. The curing material can only be removed for a half an hour. Then, after the curing period, another saw cut is made to form a reservoir. The reservoir also has beveled edges. In fact, it's the same procedure as I mentioned earlier for sealing transverse joints. Finally, tape bond breaker is placed in the bottom of the cut, followed by sealant. And that covers joint construction. We've covered a lot of ground in this program. Preparing the area, patching joints, placing the concrete, finishing, curing, sealing, and some of the details on joint construction. There are details to attend to in concrete patching. As I said earlier, know your references before the work starts. The contract, the special provisions, and the specs. If the work is done properly, and that means according to the specs, concrete patches can last for years. It's all a matter of high-quality materials and correct work methods.